Good morning, parents, teachers, and learners. We are now on Quarter 3, Week 6, wherein we will discuss similar figures and similar triangles. At this point, let me ask you the following questions. Have you ever tried to copy an image by drawing using scale? Did you experience having a task where you need to copy a smaller drawing and turn it to its bigger version? Have you ever made a sample blueprint of a park in Valenzuela, like the Valenzuela City Sports Park? Or how about any structure your dream house may be? How big is your living room? Where is the master's bedroom located? Or have you ever tried to make a miniature of a structure? Have you seen the miniatures of hotels and condominiums in some malls? Did you know that in Museo ng Valenzuela, you can find a life-size image of Arcong Bato? These questions that I presented you a while ago are some of their applications. But when can we say that figures are similar? A figure is similar to another if and only if the following conditions are satisfied. The first one, corresponding angles are congruent. And the second one, corresponding sides are proportional. We should make sure that the two conditions are satisfied in order for us to say that the figures are similar. Similar figures are also denoted by this symbol. It is called tilde. Let us have some examples. Example number 1. Suppose that quadrilateral ABCD is similar to quadrilateral WXYZ. Determine the pairs of congruent angles and proportional sides. First, it is important to know the correspondence of the vertices before naming the pairs of angles and sides. It requires the proper pairing of vertices from one figure to another one. Vertex A of quadrilateral ABCD corresponds to vertex W of quadrilateral WXYZ. Vertex B corresponds to vertex X. Vertex C corresponds to vertex Y. And lastly, vertex T corresponds to vertex Z. After knowing the correspondence or the proper pairing of the vertices, correspondence or pairing of angles and sides can be made. We should take note that the order of the vertices is important when naming corresponding sides and angles. Angle A of quadrilateral ABCD corresponds to angle W. Based on the definition of similar figures, their corresponding angles must be congruent. So therefore, we can say that angle A is congruent to angle W. Next, angle B corresponds to angle X. So therefore, we can say that angle B is congruent to angle X. Angle C corresponds to angle Y. Therefore, we have angle C is congruent to angle Y. And lastly, angle D in quadrilateral ABCD corresponds to angle C of quadrilateral WXYZ. So therefore, we can say that angle D is congruent to angle C. After enumerating the congruent angles, let us have the correspondence of the sides and their relationship. Side AB of quadrilateral ABCD corresponds to side WX of quadrilateral WXYZ. Hence, we can say that we can make the ratio AB over WX. Segment BC or side BC corresponds to side XY. That has the ratio BC over XY. Side CD corresponds to side YZ, having the ratio CD over YZ. And the last pair of sides, side DA corresponds to side ZW. Thus, we have the ratio DA is to ZW. Let us get the ratios made. Based on the definition of similar figures, the sides are proportional. So we can say that the ratios are all equal. There. Since quadrilateral ABCD is similar to quadrilateral WXYZ, the following corresponding angles are congruent. And the ratios of the sides form a proportion. Let us now proceed to another example. Example number 2. Given triangle DEF is similar to triangle ABC, determine the congruent angles and proportional sides. In order for us to determine the congruent angles and proportional sides, let us make sure the correspondence or pairing of the vertices. Vertex T corresponds to vertex A, vertex E corresponds to vertex B, and vertex F corresponds to vertex C. From the statement, triangle DEF is similar to triangle ABC, and the correspondence of the vertices, we can name the pairs of corresponding angles that are congruent. The first pair, angle D, is congruent to angle A. Next, angle E is congruent to angle B. And the last one, angle F is congruent to angle C. Now, let us have the ratios of the sides. Let us have the first ratio, DE over AB. The ratio of the sides, EF over BC. And the last ratio can be made between the sides DF and AC. Since the two triangles are similar, the ratios of the sides are equal. Let us now go to example number 3. Triangle OPS is similar to triangle XYZ as shown in the figure. Find the measure of angle O, angle B, angle S, the length of OP, and the length of YC. From the similarity statement and the figures, we can say that vertex O corresponds to vertex X, vertex B corresponds to vertex Y, and lastly, vertex S corresponds to vertex Z. Hence, we can say that angle O is congruent to angle X. If angle X is 30 degrees, we can say that angle O is also 30 degrees. Next, angle B is congruent to angle Y. If the measure of angle Y is 70 degrees, therefore we can say that angle B also measures 70 degrees. Lastly, angle S is congruent to angle Z. If angle Z measures 80 degrees, therefore we can say that angle S also measures 80 degrees. Still working on the same problem, let us find the measures of the missing sides. How are we going to find the lengths of OP and YZ? At this point, we need the scale factor. What is a scale factor? It is the ratio of the length of one side of a figure to the length of its corresponding side of the other figure. The symbol used to represent the scale factor is K. Note that the two triangles are similar, so we can form a proportion out of the ratios of the sides. We obtain OB over XY, BS over YZ, and SO over ZX. The ratios are equal. Then let us substitute the given measures. OB measures OB, while XY measures 16. That is why we have OB over 16. Next, BS, we have the measure 5. YZ is missing, so it is still YZ. And the last one, SO measures 7, and ZX measures 14. That is why we have 7 over 14. We need to consider and identify the ratio of the known corresponding side lengths that can be used in solving for the unknown lengths of the other sides. Hence, we can use the ratio of SO over ZX, which is equal to 7 over 14. And if we are going to simplify, that would just be equal to 1/2. Out of the scale factor, we can get the missing side lengths. Let us have the length of OB. We need to form a proportion using the ratio that has the side OB in it and the scale factor. So therefore, we will be using OB over XY and SO over CX. Let us equate them. Substituting the values of the lengths, we will obtain OB over 16 is equal to 1/2, which is our scale factor. Applying the means and extremes theorem, we will multiply OB times 2. It should be equal to the product of 16 times 1. The result is now 2OB is equal to 16. To get the length of OB, we divide both sides of the equation by 2. Therefore, the length of OB is 8 units. Now, let us find the length of the last side, which is YZ. Again, we need to form a proportion using the ratio that has side YZ in it and the scale factor. So it will be the ratios BS over YZ and SO over ZX. Let us equate them. Substituting the lengths of the sides, we will obtain 5 over YZ is equal to the scale factor 1/2. Applying the means and extremes theorem, multiplying 5 times 2 is equal to the product of the means. That will be YZ times 1. Simplifying, the result will now be 10 is equal to YZ. So therefore, by symmetric property, YZ is equal to 10 units. Next, let us proceed with example number 4. If quadrilateral ABCD is similar to quadrilateral EFGH, find each of the following. Number 1, the scale factor of ABCD to EFGH. The second one, the length of EF. Next, the length of FG, the length of GH, the perimeters of ABCD and EFGH, and the ratios of the perimeters of ABCD to EFGH. Let us determine the proportion that can be formed using the ratios of the sides of the two similar quadrilateral. For us to find the scale factor, we will be having the ratio of AB over EF. That should be equal to the ratio BC over FG and equal to the ratio CD over GH and DA over HE. Next thing to do is to substitute their respective measures. AB is 24 and EF is X. That is why we have 24 over X. Next, BC is 12 and FG is Y. That's why we obtained 12 over Y. CD is 20 and GH is Z. That is why we have 20 over Z. And the last one, DA measures 8 and HE measures 6. That is why we have 8 over 6. The scale factor that we can use is the ratio, correct, DA over HE, which is equal to 8 over 6. This has the lowest term, 4/3. Out of this scale factor, we are now ready to find the measures of the lengths of the missing sides. Let us find the length of EF. We need to find the ratio with EF in it. So we will be using, correct, AB over EF and equate it to our scale factor, DA over HE. Substituting the measures, that will become 24 over X is equal to our scale factor, 4/3. Applying the means and extremes theorem, 24 times 3 must be equal to the product of X times 4. By multiplication, we have 72 is equal to 4X. We need to divide both sides of the equation by 4 for us to get the value of X. The result is now great. 18 is equal to x. By symmetric property, we obtain the value of x which is equal to 18. Since x stands for the length of EF, therefore we can say that EF measures 18 units. Now, let us proceed in finding the length of FG. Same process will be used. What pair of ratios are we going to use? That's correct. We will be using BC over FG and equate it to the scale factor dA over HE. Next, let us substitute the lengths. We now have 12 over y is equal to the scale factor 4/3. Applying the means and extremes theorem, 12 times 3 must be equal to the product of y times 4. By multiplication, we have 36 is equal to 4y. Divide both sides by 4 for us to get the value of y. The result is now, very good, 9 is equal to y. By symmetric property, we obtain the value of y which is equal to 9 units. Since y stands for the length of FG, therefore we can say that FG measures 9 units. Let us solve for the length of the last side, and that is side GH. To find the length of GH, we need to find the ratio with side GH in it. So that will be CD over GH. And we need to equate that to our scale factor dA over HE. Substituting the lengths, we have 20 over Z is equal to the scale factor 4/3. Next, let us apply the means and extremes theorem, multiplying 20 times 3. And it must be equal to the product of Z times 4. By multiplication, we will obtain 60 is equal to 4Z. We only need the value of Z, so therefore we need to divide both sides of the equation by 4. The result will be, that's correct, 15 is equal to Z. So by symmetric property, we can say that Z is equal to 15 units. Since Z stands for the length of GH, therefore we can say that GH is equal to 15 units. For the next questions, we are asked to find the perimeter. To find the perimeter of any polygon, we need to add the measures of the sides of the following polygons. The perimeter of the quadrilateral ABCD is just adding 24, 12, 20, and 8. Adding them will result to 64 units. How about the perimeter of EFGH? What is your answer? Adding the sides, that will be 48 units. The last question, we need to find the ratio of perimeter ABCD over perimeter EFGH. The result will be 64 over 48. And if we are going to simplify this fraction, it is equivalent to 4/3. If you can observe, since the ratio of the perimeters is similar to the scale factor 4/3, we can now say that the ratio of the side lengths of two similar figures are proportional to the perimeters. So let us sum up today's discussion. A figure is similar to another if and only if the following conditions are satisfied. Corresponding angles are congruent and corresponding sides are proportional. Similar figures are denoted by this symbol, which is called as tilde. Next, in solving for the unknown side lengths of similar figures, the scale factor is used. It is the ratio of the length of one side of a figure to the length of its corresponding side of the other figure. The symbol used to represent scale factor is K. The ways or approaches in achieving our goals in life might not be similar. One might achieve it fast, while others are still striving to reach the fulfillment of his dreams. You should keep your hopes high and make your outlook in life always positive. Maybe these are some similar traits of people beyond their success. We might be tired of everything we do. Well, that's normal. Take a rest. Pamper yourself for a while. But you should never give up. Who knows? Success is just a millimeter away from you. So this is Mr. Jude Carlo M. Pilapin, your live streaming teacher for today. Good day, stay safe, and God bless.